Hi, this video I am going to tell about the various phases of compiler. What is meant by compiler means compiler will translate the source program into object program. To convert the source program into object program, there are various phases we followed in compiler. There are 6 phases, namely lexical analysis, syntax analysis, semantic analysis, intermediate code generation, target code generation, and code optimization. So these are the 6 phases of compiler. In addition to that, we have symbol table management as well as error handling recovery is also there. We will see one by one what form it will be converted in every phase. As I told, we have 6 phases. So we will give input as a source program, and that program will be translated into a target program. In between, we have 6 phases are there. So each phase transforms a source program from one representation into another representation. So initially, we will give the source program into lexical analyzer. Lexical analyzer produce the tokens. That token is given as an input for the syntax analyzer. Then syntax analyzer converts the tokens into parse tree. During the semantic analyzer, if there is any type checking is there, means that is performed by the semantic analyzer. Then that parse tree is given as an input for the intermediate code generator. That intermediate code generator will convert the parse tree into intermediate code. There are so many intermediate code we have. So any one intermediate representation it will convert. Then code optimizer. Finally, we have code generator. So in addition to the 6 phases, to communicate errors, we have error handlers are there, and whatever identifier we used in the expression, that identifier is stored in the symbol table. First one is lexical analyzer. The first phase of the compiler is a lexical analyzer. So what the lexical analyzer will do is it reads the source program character by character and returns the tokens of the source program. As I told, input for the lexical analyzer is a source program, and output it returns the tokens. So what is meant by tokens actually? Token describes a pattern of characters having the same meaning in the source program. So the different types of tokens are identifiers, we have operators, keywords, numbers, delimiters, and so on. So these are all different tokens. For example, here I have taken new value equal to old value plus 12. So here new value is an identifier, then equal is an assignment operator, old value again is an identifier, plus is an operator, so it is an addition operator, and 12 is a number. So here I have used 2 identifiers, so these informations are stored in the symbol table, like identifier 1. So identifier 1 is new value, and identifier 2 is old value. So these 2 are stored in the symbol table. And so other name for the lexical analyzer is parsing actually, sorry, scanning. So as I told, the source code will take the stream of characters and converts into meaningful sequence. So what is that sequence is called? We call it as a lexeme. So lexical analyzer, what output it produces by the lexical analyzer, it is a token. So it gets the source program as an input, and it produces a token as output. And it is passed to the next phase. So the next phase is a syntax analysis. So one more example here I have mentioned. So position equal to initial plus rate star 60. So this is a example I have taken. This is a source program. Assume that this is a source program. How many lexeme we have is there are 7 lexemes. First lexeme is a position. So position actually it is a lexeme mapped into token identifier. So token contains 2 parts. One is a token name and the second one is an attribute value. Here what is a token name is identifier and attribute value is 1. So this 1 it is used for refer the symbol table. So 1 points to the symbol table entry for the position. Then second token is an assignment symbol, that is equal. So that is mapped into equal symbol. Then initial. So what is initial is it is an identifier. So So it contains two parts, id comma 2. So 2 means it is a symbol that is pointed to the simple entry for that particular position. Then we have a plus. So plus is again an operator. Then rate. So rate is again an identifier. So already we have listed 1 and 2. So this one is a third identifier. So id comma 3. So then star, it is a multiplication operator. Then 60, it is a number. So these are the different token we got from the lexical analyzer. Then we have these are the three important keywords used in the lexical analyzer: token, pattern, and lexeme. What is token means? It is a sequence of characters that can be treated as single logical entity. And we have different types of tokens like identifiers, keywords, operators, special symbols, and constants. So then we have a pattern. So what is meant by pattern means it is a set of strings in the input for which same token is produced as output. And lexeme means it is a sequence of characters. For example, in the previous expression we have initial. So initial means it is a sequence of characters. So that is matching with identifier. So that is one of the lexeme. Similarly, plus is an operator. So like that, so whatever lexeme we have, the corresponding token is produced. And symbol table management. What is the purpose of symbol table management is, it is one of the data structure holding information about all the symbols defined in the source program. So whatever symbol we used, for example, we used identifier in that particular expression. So whatever the expression I have used, here I have used three identifiers, ID1, ID2 and ID3. So 1 denotes for position, 2 denotes for initial and 3 denotes for rate. So these three are mentioned in the symbol table. Then second phase is a lexical analyzer, syntax analyzer. So the role of the syntax analyzer is to convert the token into parse tree. So the other name for the syntax analyzer is a that is parse tree. So we may call it as a parser actually. So what parse tree will do is it will produce as a syntactic structure from the token. So what we will do in parse tree is all the terminals are at leaves, all the inner nodes, whatever inner nodes we are using, all are non-terminals in the context-free grammar. So this is an example, the same example what we have used. So ID1 equal ID2 plus ID3 into 60. So it takes a token produced by the lexical analysis as input and generates a parse tree. So here we take as a inner node. So here star is an operator. We have left child ID3 and right child is 60. Similarly, plus is a root node. ID2 is a left child and this entire expression is a right child. Then again equal is an assignment operator. ID1 is a left child and the entire expression is a right child. So this is about the syntax analyzer. So as we know, parsing, we have two different parsing techniques are available. One is a top-down parsing and other one is a bottom-up parsing. So what is meant by top-down parsing means it constructs the parse tree from root to the leaves. So it will starts with the root and parsing will be done, parsing proceeds towards the leaves. So we have two different parsing techniques we use it for top-down parsing. One is a recursive descent parsing and other one is a non-recursive descent parsing. These are the two top-down parsing methods. Second technique is a bottom-up parsing. What is bottom-up parsing means? It constructs the parse tree at the leaves. It starts at the leaves and proceeds towards the root. That's about the bottom-up parsing. So we have so many bottom-up parsing techniques available. One of the popular technique is shift reduce parsing. Then we have operator precedence parsing. And the third one is a LR parsing. So LR parsing alone, we have three different types of LR parsing. One is a SLR, second one is a CLR, and third one is a LALR. LR, that is what is meant by LR means L denotes for left to right scanning and R denotes for rightmost derivation in reverse. Okay, next one is semantic analysis. What is semantic analysis is, it will check whether the parse tree constructed follows the rules of the language. For example, if there is any type checking, we have suppose we have sometimes we may get a data type mismatch. So those and all will be corrected during the semantic analysis phase. So it gathers the type of information and saves it in either in the syntax tree or in the symbol table. So this is actually the third phase, how the second phase input is converted into third phase. So here what the type checker do here is, suppose that position, initial and rate have been declared as a floating point numbers, and the lexeme 60 by itself forms an integer. So assume we declare these three variables as a floating point, but 60 is assumed as integer. So we have a data type mismatch between integer and floating point. So what the type checker will do is, it converts the integer into floating point. So that's what done it here. So 60 is an integer number, so that 60 is converted into floating point number. So integer, in this case, integer may be converted into floating point number. Then fourth phase, it is an intermediate code generation. So what is the purpose of the intermediate code generation is, before generating the machine code, some intermediate code is generated. So for that purpose, we use the intermediate code generation. So it represents a program for some abstract machine. So it is in between the high level language and machine level language. So final language, what we got from the compiler is a machine language. So before that, some intermediate language is generated. So that is generated by intermediate code generation. So we have some example here. So what we have done is, here we use 3 address code as an intermediate representation. We have so many intermediate code generation format of representation. We have 3 address code, quadruple, triple, then indirect triple. These are the different intermediate code we can generate. So here I have used the 3 address code. So first one from this example, so we are converting int to float, that is number 60 is converted into floating point. So int to float of 60. So 60 is an integer, so that we are converting into floating point number, that we store it in one temporary variable t1. Then second one, id3 into t1. So id3 into 60 we normally did in the previous phase. So id3 into t1. Then t3 equal id2 plus t2 and id1 equal to t3. So this is about the intermediate code that we generated from the parse tree. And fifth phase is a code optimization. So what is the purpose of the code optimization is, so we can remove some unnecessary code lines and arrange a sequence of statements in order to speed up the program execution without wasting any resources. So here previously in intermediate code generation we have generated 4 statements. So that 4 statement is reduced into 2 statements. So for example, int to float of 60, we can directly write it as 60.0. So there is no need of this line t1 equal to int to float of 60. So instead of that, we directly write 60.0. So automatically that 60 will be converted into floating point. So then this id3 into t1. This instead of this t1, we are directly multiplying id3 into 60. So then these 2 statements is replaced by a single statement, that is id1 equal to id2 plus t1. So here what is the purpose of the code optimization is to reduce the number of lines, that is removing the unnecessary code lines. So when we reduce the unnecessary lines, automatically your code will be executed much faster. And the final phase is code generation. So in this phase, the code generator takes the optimized representation of the intermediate code and maps into target machine language. So whatever optimized code we got from the code optimization, so that code will be mapped into machine language. Suppose if the target language is a machine code, then registers or memory location are selected for each of the variables used by the program. So whenever we use machine code, we have to use registers or memory locations for storing your variables. So intermediate instructions are translated into sequence of machine instructions that perform the same task. So finally we got the machine language. I'll show the example here. So here actually we use registers. As I told, we use register and memory location when we write the machine code. So here I have used two registers, R1 and R2. So intermediate code might get translated into machine code. So first one, so this is a example instruction. First line, it is a LDF. LD denotes for load operation. F denotes for floating point. Initially, what I did is I'm loading the ID3 into R2. So second line, I'm doing the multiplication. MUL denotes for multiplication and F denotes for floating point. So I'm multiplying R2 and 60 and store the result in R2. So 60 is a floating point number. So because this is a constant value, so it is preceded by hash symbol. So I'm multiplying R2 and 60 and storing the result in R2. Then again ID2 is loaded into R1. Then I'm adding R1 and R2 and store the result in R1. Finally, I'm storing the R1 into ID1. Store, STF denotes for store. So this is the phase by phase answer. So what I did is I'm giving the source program position equal to initial plus rate star 60. That is given as an input for the scanner, the other name for the lexical analyzer, and we got the tokens from the first phase. So position, what is the token name is ID1, then equal, initial is ID2 plus rate is ID3, then into 60. So symbol table I have three identifiers. So that three identifier 1, 2, 3, then name of the identifier. What is the variable name? 1 denotes for position, 2 denotes for initial, and 3 denotes for rate. So then we have parse tree. So this ID3 and 60. So here star is an operator, ID1 is a left child, and ID3 is a left child and 60 is a right child. So then plus ID2 is a left child and this entire expression is a right child. Then again equal, ID1 is a left child and the entire expression is a right child. Then semantic analyzer, we have the type checking. So we assumed that position, initial and rate are floating point. So 60 is a number that we are converting into floating point. So then we got intermediate code generator. We have written the 3 address code. Then code optimization. That 4 statement is reduced into 2 statement. Finally, I have written the code optimization. Thank you.